So we're going to look at urban settlement issues that we experience, as well as rural settlement issues that we experience. But we're going to see how climate also plays a role and also can cause problems in these urban settlements. So what we're basically going to do today, we're going to combine a little bit of climatology into its local climate, into the urban settlement issues that we experienced. And we're going to discuss that, okay? But I'm using the reference of last year's final exam. So I hope you do have that question paper close by. If not, please take notes, okay? So our first question is regarding urban climate, local climate. Now, if you look at figure 2.4, what we have over here, we have the differences between rural and urban climates. Now, immediately, if you look at the two photos that's been presented to us, A, we can identify as a rural area. How do we know that? Because we can see farming is taking place. Okay, now farming is a rural area. What happens in rural areas? It's mostly primary activities. Okay, once again, great class, we need to revise. I need to remind you, primary activities, farming, fishing, forestry, and mining. Okay, now let's go back to our diagram. I want you to pay attention quickly. As you can see, I'm just going to throw everything there. This is the farmhouse. It looks like an isolated farmstead. Okay. Another thing that I want you to pay attention to, the diagram, to the photo. Apologies. Look at the photos, the clouds. Just want to use a different color pen quickly. Look at the cloud cover, because this might be important when we go and look at the questions. Okay, look at the cloud cover. Secondly, let's look at the temperature. 22 degrees Celsius. Okay. Now, if we move to photo B, first of all, immediately we can identify the area as an urban area. Now, we've discussed this before. What is urban areas? Where we find secondary and tertiary activities. Okay, if we look at urban areas, where does it start? From a town to a city to a metropolis conurbation. Okay, keep that in mind. So we focus on secondary and tertiary activities. I'm just adding it over there. We can see it's a build-up area. Now, what we've learned so far as well, if you look at the tallest buildings, the high-rise buildings, if we look at an urban settlement pattern, if you look at an urban profile, can you remember what an urban profile is? It's a side profile of the river. Now, usually, if you look at the tallest buildings, where will we find the tallest buildings? CBD. Okay. So we can identify photograph B, the CBD of the urban area. Okay. And once again, pay attention to the temperature. If I'm not mistaken, what's the difference in temperature between the rural area and the urban area? 10 degrees Celsius. So that means that the rural area is much cooler. Okay. Now I'll explain to you this point over here, because this is where we need to pay attention. This is where the question arises from. So, because they're shown as these two photographs, one is 22 degrees Celsius, the other one is 32 degrees Celsius. So we can assume that the rural area is much cooler than urban areas. Or we can say the urban areas experience much warmer conditions than the rural areas. But the reason, we need to ask ourselves why. Okay. Now coming back to last year's final question paper, and it's question 2.3.1. F 2.4. Refer to figure 2.4 based on the differences between rural and urban climates. But once again, keep in mind, it creates issues, especially in urban areas. Now, the first question states 2.4.1, will A or B generally experience lower wind speeds? Now, what is wind? Okay, it's the movement of air. As a grade 12 student, you used to know it's when air moves from a high pressure to a low pressure. Okay, so that is known as wind. Now the question states, where will we experience lower wind speeds? At A or at B? Now keep in mind, where are we going to experience less friction or more friction? Okay, think of the air blowing smoothly or it's going to be blowing disruptively. Okay, do you think if wind is blowing at A, is it going to blow smoothly or is it going to be some obstacles? Now if you can look over here, it's quite a flat gradient. If you look at the topography, it's quite flat. But if you look at area B, very high-rise buildings. So these high-rise buildings is going to create friction. Okay, it's going to be obstacles for the wind to blow. So if we talk about wind speed, what's going to happen at the end of the day? These massive buildings are going to be an obstruction. So if we want to go back to our question, we look at our question states, will A or B generally experience lower wind speeds? B will experience urban areas experience lower wind speeds. Okay. The simple reason for it is because the buildings causes friction. Okay. Or obstructions. Okay. So that answers our first question. Our second question states, what evidence in the photograph indicates that A experienced higher evaporation rates than B? Now, what is evaporation? Now, we're coming back to our hydrological cycle. Evaporation is when water turns into a gas. Okay. Usually because of warm temperatures, what happens? Water turns into a gas. Now, the question states, why does area A, apologies, I just want to use a different color pen over here, yellow. Why do area A experiencing more evaporation than area B? Okay, all the answers is right here in front of us. Okay, I just quickly want to clean my photos so I can write on them. Now, we discussed this. If you look at area A, why is there more evaporation at the rural areas? Okay, the simple reason, how can we tell it? First of all, look at the cloud cover. Now, in order for clouds to form, we need evaporation to take place. Okay, so what happens? Water turns into a gas, it evaporates. Okay, what happens when the gas turns back into a molecule, such as water, liquid? It's condensation. That's the reason why we have cloud cover. So if I can just do a simple flow diagram, there's your sea, the ocean, it evaporates, it turns from a liquid to a gas, and that's known as evaporation. And when it reaches a certain temperature, we call it the dew point temperature. The gas turns back into a liquid. Just going to make a little drop. And we have cloud cover. Okay. Now, first of all, we can immediately see at photograph A that we have cloud cover. Secondly, very importantly, Kathy was previously on with life sciences. Now, if you're a life sciences student, you will know that we talk about evapotranspiration. Okay, vegetation causes more evaporation. Okay, but before I'm going to get to this, first of all, have a look at all the vegetation. Now, obviously, we see cultivated land situated over there. we see trees. Okay. What else do we see? We can also spot, right, if you look at area B, less open water surfaces, less vegetation. I just want to write it over there. Okay, so what can we look over here? If you look at it, there's definitely much more cloud cover situated over there. There's more vegetation and there's more natural surfaces. Now, keep in mind, if you look at area B, everything is artificial. When I say artificial, it's man-made. Okay, concrete, pavement, tar road surfaces, glass. Okay, there's nothing natural in urban areas, especially the CBD. So the correct answer, there is definitely more evaporation in area A, and I can mention over here because we can see more cloud cover. We can see more vegetation. And by adding this, it's more natural areas. And I'm just going to add over here, urban areas in brackets, a CBD, because we refer to the photograph is artificial. Okay. Apologies, just want to get the correct spelling over here. Okay. So, we assume by just looking at the photograph, you can see there's more vegetation cover and obviously more cloud cover. Coming to our next question, that's a very important question. I like to confuse my students, even my own students, with this type of question. Now, when we compare a rural area to an urban area, now we established that the rural area has got much more evaporation taking place. Okay. We've seen on our diagram on the photos that we experience cooler temperatures. Okay. So that's two things. We experience more evaporation and we're experiencing cooler temperatures. And if you can assume, going back to the photographs, A or B, we assume that area B is much drier than area A, because area A is covered with vegetation. Open water surfaces might be very close. Now, the next question, and it's a very tricky question, and I find that the grade 12s do struggle with this question during exam times. Why does it rain more in urban areas than rural areas? I've just mentioned to you, urban areas experience less evaporation. Now, you need to keep in mind, for the purpose for rain to take place, we need evaporation. Okay. For the purpose of rain to take place, we need humid, moist air. Okay. Because we know the saying, air rises, it cools, condense, clouds, and a possibility of rain. But all of the rural areas have these characteristics. They experience much more evaporation, much more moisture, right? Why do they experience it more? Because of the vegetation cover, open water surfaces. Okay, then we move to the urban area. And the urban area, much drier climate, warmer conditions. It's warmer, yes, but where does it get the moisture from? That's the question. Why does it rain more in our urban areas? And I'm going to draw you a simple diagram to explain it to you. It's because of condensation nuclei. Okay, we need this condensation to take place, but it takes place more in urban areas than rural areas. Now I'll explain it to you now. Now I'm going to draw you a simple diagram. Let's assume this is a cross profile of, just want to use my green pen. This is a cross profile of a urban area. Okay, this is my CBD. It's my tall buildings. Okay, And further away, we have our rural areas. Okay, I'm using trees as an example because we've seen in the photographs that the rural areas is covered with vegetation. Okay, so I just want to write there. So if you look at it, this is the CBD. And over here we have our rural areas. Okay. Now, the CBD obviously is our urban areas. So we just established that our rural areas experience high evaporation. Okay. Moisture content is higher because of natural vegetation. We have open water surfaces that makes evaporation more likely. We've established that the CBD experience drier conditions. Okay. Definitely warmer conditions. The simple reason why, because it's artificial, it's fake. Okay. The buildings absorbs heat. There's nothing that cools it down. For a simple example, if you compare the CBD to the rural areas, we looked at the two photographs. Area A experienced less temperature, the correct term is lower temperature than the CBD, almost 10 degrees, because plants, vegetation's got a cooling effect, okay? But what happens over here? Now we need to go back to our diagram. Why do the CBD experience more rainfall? The simple reason, because we can always judge it as a mini high pressure, mini low pressure. We experience rapid rising air in our CBD area. Why? Because it's artificial head, we're busy, people are there, we're using machinery, we pollute, etc. Like for instance, we're creating more warmth, okay? We're creating more artificial heat. And what does heat do? It rises, okay? So I'm just going to put in there in brackets, we've got like a miniature low pressure that exists over the CBD. Now what happens? Much cooler conditions in our rural areas. And I'm just going to put it there in brackets. It's like a mini high pressure that exists. We have cooler conditions, so the air sinks. There's more subsidence taking place. Okay, so eventually, by now you should know, how does air move from a high pressure to a low pressure? Okay, so all this cool air that consists of much more moisture. Why is it full of more moisture? Because there's vegetation, there's my trees, okay? There's cultivated land, there's open water surfaces, okay? So there's a much more moisture content in the air in the rural areas than in the urban areas. So because it's cooler temperatures, this cooling air are getting sucked in by this rising air, drier, warmer conditions in our urban areas. And what happens? This moisture being sucked in, it rises, it cools, condenses, clouds, and we have the possibility of rain. Okay, so I hope that explains it to you. But just look at the question. Now the question states, why does B experience more frequent rainfall? And the reason is exactly because of that, because there's more condensation nuclei in the urban area because all the moist air are getting sucked in from the surrounding rural areas. Okay, because it's got more moisture and because of because of vegetation cover and open water surfaces. Now, let's just quickly have a look at our next question. Our next question states, explain how the geometric shape of buildings in a city causes a greater absorption of heat. Now, if we look at our image number B, the geometric shape, why does the buildings create more heat? And I just quickly want to clean this up. Now, I want you, wherever you're from, if you're from Johannesburg, think of Joburg CBD, be Hillbrayers, Braamfonteines. Think of Pretoria, think of Durban. Even if you live in a small town, right, think of town itself where the CBD is, the central business district. Now look at the buildings. They consist of what? Mainly concrete or glass. What does concrete and glass do? They reflect and absorb. Okay. Now, this reflection doesn't take usually place back into up in the sky. No, it can reflect anywhere. So the reason, because of the shape of the buildings, what do? I mean, you go to Johannesburg, you've got so many buildings over here. You go to Sandton, okay? You've got dark color buildings, you've got light color buildings. What do? They reflect and absorb. So the correct answer for that question, I'm just going to write it down there, and I'll write it down there. Reflection plus absorption. Okay, because the tall buildings, okay, this is caused by the sun rays. I just want to put that in brackets. Now, it's a larger area to absorb the sun's heat. Now keep in mind, if you look at the rural area, for instance over here, right, it's only the soil that absorbs the heat, the insulation. But if you look at the buildings in the CBD, it's all over the place, okay? And because of the type of materials used, it can be concrete or even glass, it creates reflection or absorption, okay? Now, coming to our last question regarding the problems that we experience with local climate. And it's vitally important, and not only am I going to answer this question, but I'm going to give you some solutions that we need to do to prevent this from happening, okay? Because it can cause us concern, especially when we experience already extraordinary warmer conditions in our urban areas. And the question states, in a paragraph of approximately 8 lines, discuss how artificial surfaces and urban activities contribute to higher temperatures. Now, this is the catch. You need to mention the artificial surfaces. How does the artificial surfaces create warmer conditions, as well as human activities, urban activities? Now, the mark allocation is 4 times 2. So that means 4 facts, right, for 2 marks each. So we need 2 facts regarding artificial surfaces and 2 facts regarding the urban activities that takes place in cities. Okay, how do they contribute to higher temperatures? Now, first of all, when we look at it, when we look at artificial surfaces, it's fake. Okay, what do? They absorb the heat. Now think of a tar road surface, for example, right? Dark in color absorbs much more of the heat. If you think of buildings, concrete, same as that. Now when we're talking about the artificial surface, think about drainage systems as well. What happens, we go back to this photograph over here. Let's assume we experience a high-felt thunderstorm like we usually do in summer in Johannesburg. And let's say it rains in the rural area. What's going to happen with most of the water? It's going to infiltrate. Okay. Why? Because it's covered with vegetation. Now, what happens in area B? It's covered with tar road surfaces with pavement. What's happening with that water? It usually runs off into our sewage systems. Okay, it's gone. Can't really have a cooling effect. Now, in the rural areas, that water might be on top of the surface by filling up our dams or irrigation systems or dams or rivers, etc. So because of these artificial surfaces, it doesn't create a cooling effect. So let's just write a couple of down. Just want to get to the bottom of my page. If you look at it, when we look at these artificial surfaces, concrete and metal is used. And what does it do? Retain heat. I've mentioned it. The tar roads absorbs more heat. Okay, I've mentioned it in the previous question, reflection. So instance, glass and mirror images. Reflects heat. We can also say heat is being trapped between the buildings. And lastly, like I've mentioned, stormwater after a heavy rainfall is drained by the sewage systems or by the drainage systems of a city. Okay, so we basically focus on our artificial surfaces. We looked at it, like tar road surfaces, the buildings, the glass, everything that's being used. Now, all of this creates warmer temperatures. Okay, now, what human activities, urban activities, also contribute to warmer temperatures? Coming back to our diagram, not diagram, our photos. If you look at it, great task, pay attention. 10 degrees difference between the urban area and the rural area. 10 degrees, that's quite a lot, okay. But what causes it? We look at the artificial reasons, no, factors that cause this. So what's the urban factors, human factors that causes warmer temperatures in the city areas? And the first one, obviously, is congestion. Okay, traffic. Okay, there's more movement taking place, more active people. Now, just a simple example. You can go and try that yourself. Just stick your hand, don't burn yourself, when the car is idling, all right? Just where the exhaust pipe is. What's coming out? Warm pollution, basically, carbon dioxide. Now remember, it creates a warmer conditions. It's urban activities. If you think of restaurants, okay, using grills, creating artificial heat, okay. If you think of corporate companies, especially during summer, especially during winter, to keep themselves cool, what do you use? AC, air conditioning, okay. This creates artificial heat, okay. Air conditioning is when it's extremely warm, or they experience when it's cold, they switch on the air conditioning. Okay, it creates artificial heat. So we can also write there, we're generating heat through restaurants, the cooking methods, and then I've mentioned, if you look at it, appliances such as ACs, stoves, and very importantly, now let's just quickly integrate it. What type of industries do we find in the CBD? Light or heavy industries? light industries. Okay, where do we find the heavy industries? Usually on the outskirts of urban areas. Why? It's creating too much pollution, noise pollution, too much noise pollution, air pollution as well. So light industries are very close. Think of bakeries, think of textile industries. Okay, and these light industries are situated in the CBDs. And lastly, what we can say is construction activities also create a lot of heat. Now, yes, I know we're done with the question, but I want to highlight the problems that these high temperature conditions can create. Now, my next question to you is, how can we succumb in it? How can we prevent it? Now, as we can see, if we look at our photo, we can see a 10 degrees difference between the rural areas and the urban areas. What can we do? You as a geography student, what can you do to reduce urban heat islands? Okay, that's basically what's been indicated over here at photograph B. What is an urban heat island? When we experience urban area experience warmer temperatures than the surrounding rural areas. So it's an urban heat island. If I had to go and draw a diagram, a cross section, I'm going to use this one quickly, and I'll just wipe it quickly clean. If I had to go and show you what an urban heat island looks like, okay, and put this on a graph. Now let me just start bloody over. Apologies, because I've been written too much. So let's assume I need to go and draw an urban heat island. There's my urban profile. There's my urban area. Okay, here's my rural areas covered with vegetation, farmland, whatever. Okay, and here's my temperature. On my x-axis, let's say for instance this is 10 degrees Celsius, this is 20 degrees Celsius, and this is 30 degrees Celsius. Okay, now what happens? What's an urban heat island? As you can see, the temperature increases over our urban area. Now we just looked at it. Why is it warmer over here? Because of artificial surfaces and because of human activities. Now my question to you is, how can we reduce it? Okay, some brilliant innovative ways. I mean, if you look at California, for example, instead of having black tarred road surfaces, what have they done? They've painted them white. Why white? Because white reflects. Dark objects absorb. Okay, the white objects reduces the absorption of heat. So that's how they've done it. The easiest way to do it, great fellows, first of all, afforestate. What do we need to create? We need to create more green belts in our CBD areas, like parks. Plant more trees. Even better if you can get open water surfaces. Keep in mind, water has a cooling effect. Now, just imagine, you must find yourself close to a dam or to a river. You will find that it's much colder close to a dam or water because it has a cooling effect to the surrounding rural areas. Okay. Inner city farming, great idea. Okay, especially with dilapidated buildings that's run down. Okay, create opportunities, entrepreneurship. Okay, another one, very important, we discussed it. Human activities create warmer conditions. Congestion, the cars going in and out of the CBD. Okay, creating more pollution, adding to this urban heat island. What can we do? Cycle to work. It's anyway healthier for yourself. You get some exercise in. So you reduce transmission gases. Okay, carbon dioxide. Using public transport, for example. For instance, like buses. Think of it, great souls. Moving into a CBD. talking Pretoria, Durban, Cape Town, how many cars will we reduce on our national freeways if all of us use buses or all of us use trains as transport? Okay, so all of these ways, public transport, greening our urban areas, creating green belts like parks, will bring down the temperature. Okay, vitally important.